So the question may arise at some point using EMO of how to add a new line. Now that can only be done in a forecast, and I have a forecast here and I'm looking at circuits. There is a new column for SFT parameters, and SSW stands for summer, shoulder and winter. So any new line you wish to be protected by SFT constraints needs to have these data fields filled in. So there's one set of 3 parameters for summer, followed by a semicolon, followed by the shoulder parameters, semicolon, and winter parameters, corresponding to the summer, shoulder, and winter rating values. These 3 parameters are the PF and PFQ values, which are calculated internally by EMO, and the percentage threshold, which will be applied to the SFT constraints as they're calculated for inclusion within dispatch. So this raises the question of where do we get the PF and the PFQ values from for a new line? Because if we enter a new line, and I've got one here, then we will need to find those parameters and enter them accordingly, along with summer, shoulder and winter ratings. Now this is where the SFT calculator comes in handy. I'm going to pick a line as an example, ATI TRK 1.1. Here it is here. And if we look in the SFT calculator at the same line, for the summer period, we have a PF of 1.19 and a PFQ of 0.04 to 2 decimal places. And sure enough, EMO has carried those into the summer field of the SFT parameters. The shoulder values are calculated using the shoulder temperature assumption, and we need to enter the capacity as well, which is 352. So a different capacity for shoulder relative to summer. And that gives us this time to 2 decimal places PF of 1.19 and PFQ of 0.03. And those are shown in the next field of parameters in the SFT parameters column. So returning to our new line, where would we obtain the relevant parameters for this new line? We will need to make some assumptions about that new line. For example, the voltage, the number of conductors, the offload time in minutes, and the Tmax. Tmax will be determined ultimately by the maximum amount of sag that's allowable, and if you want to determine that accurately, you may need to talk to Transpower if it's a new line which has been planned in some detail, or you may need to make an educated guess. So if we imagine that we're adding a new line and we're using the SFT calculator to determine the PF and the PFQ parameters and the rating values for summer, shoulder and winter, we would perhaps base our choice of parameters on an existing cable. And since I've already got ATI TRK 1.1 up on the screen, I will use that. Perhaps we're assuming a different conductor. We could go through and select one. Now, for the summer, assuming that we have made a good selection of the number of conductors, the offload time and the voltage, we would need to determine a realistic rating value. Now, with this particular conductor that I've chosen, the Tmax, the steady state temperature of the cable, is well over 200 degrees C, which is probably a little bit on the high side. So I could ramp this rating value back to get a more realistic Tmax. I might decide, for example, that a Tmax of around about 75 degrees would be appropriate. It's sitting at 78, so I'm going to say that's close enough. So I would enter into my new line a summer rating of 200, and the corresponding parameters would be 1.04 followed by 0.02 2 to 2 decimal places for PFQ, and my threshold of 85%. I would need to repeat that for the shoulder and the winter ratings.